In the last class, we have seen some basic things like what is energy, what are the Newton's laws of motion, what is kinetic energy, what is actually meant by work, what is power, the basic stuff. Correct. Now we will go step ahead in this class, and I will teach you some things about atmosphere, not everything in detail. Correct. Atmosphere in detail is learned in meteorology. Here, just I'll give you gist of what is actually needed for understanding lift, drag, etc., etc., etc. Correct. Now I'll discuss every factor mentioned here to some extent. After this, I'll be teaching you two things. One is principle of continuity. Correct. Then, based on this principle of continuity, I'll teach Bernoulli's theorem. See, this Bernoulli's theorem, I will teach it in two fashion. Correct. First fashion will be what is there in the book I'm going to teach. The second fashion, I'll teach the reality. How you put this Bernoulli's theorem to make an aircraft produce lift. Okay. So if you have attended navigation from last 2-3 days, okay, so it is like I'm repeating a lot of things, but there are students who are coming directly for technical general classes, so for them it is like Greek and Latin if I go fast. So you will be also thinking, oh, sir is repeating too much, because you attended navigation and the same concepts are here. I'm repeating. Correct. This will be our plan today. I'll try to complete as soon as possible. Now, fine. What is here? Did I explain static pressure and dynamic pressure in last class? Just remind me here in technical general.
No, sir.
No.
So not in brief, just
Only in brief. Correct.
yeah.
See, if I say the atmospheric pressure is equals to 1013.25 hectopascals. Can someone say, like, Zara, what do you mean by 1013.25 hectopascals?
Sir, it's the pressure that any body will feel standing at the sea level.
Correct. Anyone or any aircraft or any human being at sea level will feel 1013.25 hectopascals static pressure. That means assuming the air around the human being or the aircraft is not moving at all. Correct. So this is static pressure 1013.25 hectopascals. Did I convert it into PSI and?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So you understand how much is the force of the static pressure. Correct. Now, see, as you go up, what happens to the static pressure?
Decrease.
It decreases. Correct. So by how much? Static pressure decreases by
Every 30 feet.
Every 27 feet.
correct. Static pressure decrease as you go up by 1 hectopascal per 27 feet. Correct. So this is static pressure. Now, did I explain what happens in a fast moving car if you put your hand out?
It will push.
In the technical general class.
Yes, sir.
Okay. What happens? Zara?
No, sir, you didn't like have taken this example.
Okay. Fine. I have explained them in navigation. Zara, do you have a car?
No, sir. But I have like experience.
Okay. So you went in a car.
Hmm.
So whose car it was? Your dad's?
No, like driver's agent's car. We hired it for rent.
Okay. So does your driver drive very fast?
Yeah, sometimes on the highway. Yeah.
Okay. So what is the maximum speed your driver can go? You would have seen.
Maximum, I have seen 80 to 100 maximum.
80 to 100 and you're thinking that is fast.
But I like thought it was fast.
Okay.
Because like in our family, everyone drives so slow.
Okay. You are the one who is going to go at 200 knots. Rotate.
Yeah, that's why I want to like set an example.
Okay, fine.
But yeah, people can go up to 150, 120. Like I have seen my friends putting a status in their Instagram stories.
Yeah. See, for example, you are going on a tour.
Yeah.
Like, I never get that movie correct. The Highway. Have you seen Highway? Alia Bhatt.
No.
You don't watch movies here?
I watched, but I haven't seen that movie.
You are missing good movies here. It was a good movie. Okay, so
Okay.
Hrithik Roshan, which was that movie? The Four Friends. Zindagi Na Milegi Dobara.
Yeah.
So when the car is going, what does Hrithik Roshan do? Okay. The
Yes.
car is going at 40 to 50 kmph. That's all.
Hmm.
Now, what happens if the car is going at 150 kmph
Hmm.
and Hrithik Roshan puts his hand out? What happens to the hand?
The hand will like go backward.
Go backwards. Hrithik Roshan will say, "Oh,
No, not that much.
huh?
No.
Oh, you put out your hand once.
Yeah, but it won't
It will be
pain
painful,
like
yeah.
that.
No, it will be painful.
Okay.
Okay, don't back up Hrithik Roshan. It will be painful.
Okay.
Okay.
Hmm.
So, see what happened when the Hrithik Roshan has put his hand out. See, he's trying to go against the wind. Or if you think Hrithik Roshan is stationary and the wind is blowing at 150 kilometers per hour, it is pushing its hand piche.
Hmm.
You understand?
Hmm.
So now, is this static pressure
No.
on the Hrithik Roshan's hand?
No.
It is. See, static pressure is always there. If not, the contents of Hrithik Roshan will come out of his body. Correct. But the extra pressure that caused his force to go back, is called dynamic pressure.
Okay.
As simple as that. So it is due to the kinetic energy or the movement of air molecules.
Okay.
Correct. So, for example, I said this static pressure is happening when the wind is static, not moving. Correct. For example, if there's a cyclone going on and the wind is coming like this, correct, I'll be forced to slip like this. Correct. So now I have static force also, static pressure also, and the extra force or extra pressure is dynamic pressure that is causing me to move to my left. Understand? So dynamic pressure is represented by Q, or it is represented by small q sometimes. Now tell me, the pain in the Hrithik Roshan hand, correct, depends on what?
The speed of the car.
Very good. So dynamic pressure depends on speed of the car. Any other thing you can think on which the dynamic pressure will depend?
Like this, how much strongly he will hold his hand. Like.
Okay. See, what is meant by density? The closeness of molecules in a substance. Density is nothing but the mass contained per unit volume. Yes or no? Correct. Yes. Let's say today it is, this is Hrithik Roshan's car. Okay, this is Hrithik Roshan's hand. Okay. Today, let's say it is very cold. When it is very cold, what happens to the density of air around the car? Increases or decreases?
So increases.
Increases, correct. That means number of molecules are closer to each other. Many molecules are hitting Hrithik Roshan's hand than a single molecule. Then less number of molecules, correct. So that means in a winter, at that speed, if you put your hand out, it will pain more, correct. So dynamic pressure depends on the speed of the car, also depends on
Density.
density. Am I clear on this?
Yes.
Now, dynamic pressure, sorry, is equals to half into rho into V square. This is the formula for dynamic pressure. Rho is density, V is speed, correct. Q represents dynamic pressure. Am I clear on this? Okay. Now, let's take Delhi. This is a hill. This is Shimla. Okay. Let's say this Delhi is at mean sea level. Assume. Okay. Now Shimla is on a hill which is away from mean sea level. Correct. So this is a runway. This is a runway in Shimla. Okay. So this is not Shimla. This is Shimla. Now, first scenario, pressure. Where is the pressure more, Delhi or Shimla?
So Delhi.
Why?
Because it's
Because then the altitude of Shimla is high.
and
Pressure
we-
will decrease.
yeah, so
Correct.
we move upwards, pressure will decrease.
Because see, if you take this as earth, correct. So this is Delhi, this is Shimla on a hill. This is Shimla, correct. So all the air molecules are there like this. So the Delhi is at a lower level, so it has more weight of these extra molecules than Shimla. You understand? So Delhi has more pressure than Shimla, correct. Can I say as you go up, the pressure decreases?
Yes.
Answer next question carefully. Temperature. Where is it more? Shimla or Delhi?
So Delhi.
Delhi.
Delhi. Why? Why Delhi? Why not Shimla?
Because the atmosphere is heated by the Earth's surface, not the sun
Okay,
directly.
there is earth surface beneath Shimla also.
But it's on a higher level, na? It's away from the.
Because the temperature decreases as we go up.
I understand, but why?
Sir, pressure high. It strikes with a lot of energy,
So
which
because
causes the temperature rise.
there are more molecules in Delhi, as we said, so they will get more heat. No?
Yes, sir.
See, if this is Earth, okay, Earth is almost a perfect sphere. Okay, see, Delhi is here, correct. 90% of the Earth is at mean sea level only. At least some parts of the Earth is at a higher level, like Shimla, like a small speck on the surface of the Earth. That's all. Okay, so here is Shimla. See, the sun, while passing its rays through the atmosphere, here sun's rays are short wavelength rays. They are very high energy rays coming from the sun. Correct. So they cannot heat the atmosphere. They will pass through the atmosphere and they will hit the ground. The ground gets heated. When the ground gets heated, the air close to the ground will get heated. Correct. So now the air above it will get less heated, less heated, less heated, so on and so forth, like this. That is why the earth is heated from below, not from above. Is this understood, everyone? Okay. Now,
Yes, sir.
see.
So please explain it once again. I haven't got it.
Okay, fine. The sun is heating by something called as radiation. Correct. It is sending waves. It is sending radiations to Earth. Correct. These wavelengths sun is sending are short wavelengths. This short wavelengths cannot heat the atmosphere directly. So it will just pass through the atmosphere. It will not at all heat the atmosphere. What happens? It will heat the surface of the Earth. Understand? Now, there are air molecules touching the surface of Earth like this. Correct. Now, these air molecules close to the surface of the Earth are heated more. Correct. The air molecules above them are heated less because the heat has to pass. Correct. The air molecules above them are still less heated. Less heated. So that is the reason. So as you go up from the Earth, the temperature decreases. Correct. So what is this called as? Decrease in temperature with height from meteorology?
Lapse rate.
Lapse rate.
Lapse rate. Correct. So until tropopause, what is the lapse rate?
2 degrees for every
It is 1.98 or approximately 2 degrees centigrade per every
1,000 feet.
1,000 feet. Okay. So this is the lapse rate. Am I clear on this? Now see, Shimla is here at a higher level when compared to Delhi. Correct. But 90% of the earth is heated from here. Is heated from here. Correct. So this air keeps on moving like this also. Correct. Sideways also. So that means the air at the Shimla is coming from a place over Delhi or somewhere like that, nearby areas. Yes or no? Correct. That means here at this level, whatever temperature is there, that will be at Shimla also. That is the reason Shimla is colder. You understand? It is not because if you say, sir, earth is being heated from the bottom, here Shimla is at a higher level, but under Shimla there is ground, correct? It should heat the air, but no, the wind also moves like this, correct? So let's say if this is Delhi, so this air might have moved over to Shimla, or some other places air might have moved over Shimla, but this air over Delhi is cold because it is at a higher level. You understand? So that's why Shimla is cold. Understood? Am I clear on this? How many of you
Yes.
understood the real reason behind it? Clear? Good. Fine. Now Shimla is cold. Third question. If an aircraft, same aircraft, has to take off from Delhi and Shimla, okay, which airport will need a longer runway?
So Delhi.
Delhi, Shimla. Who said Delhi? Raise your hand.
Nikhil.
Others?
Delhi.
Sanesh. You are going to kill someone.
Sir, can you please repeat the question?
See, Delhi and Shimla, same aircraft is taking off. Which will read longer runway for takeoff? Is it
Sir,
Delhi?
Delhi Airport.
Think.
It's Delhi only. You're trying to trick us. You
Yes,
taught us
sir.
only in navigation.
The answer is Shimla. Now at least try to think for an explanation here. The answer is Shimla.
Just because Shimla is elevated, like,
Okay. See,
so pressure is less.
just because we discussed temperature, you're thinking
Yes, sir.
here Delhi and Shimla is colder. The air here is more dense. This is what you are thinking,
Yes, sir.
correct? But see, for you to compare the density, is the pressure in Delhi same as Shimla?
No, sir. At Shimla, pressure decrease due to height.
For example, if I say Delhi and Agra, correct? I say Delhi has temperature of 55 degrees centigrade, Agra has temperature of 25 degrees centigrade. Which will take more? The answer will be Delhi. Correct? But see, with increase in height, the fall in pressure is more pronounced than fall in temperature. Correct? So if you go higher altitude, the pressure will be less. When the pressure is less, correct? Of course, the temperature is colder, but the density will not be as much as Delhi airport. You understand? So as the altitude increases, right now, as the altitude increases, the fall of pressure is more pronounced than fall in temperature. Correct? So this will cause more decrease in density. Pressure fall will cause more decrease in density than your increase in density due to coldness. Am I clear on this?
Yes, sir.
Fine. That's why Shimla will require longer runway than Delhi. Here, whenever you are taking from in very high altitude regions, be very careful. Calculate everything. Take out your POH and look at every table. What is the payload you are carrying? What is the length of runway you will need? What is the length of runway you have? It is very important never to cross here, because pressure is less. If pressure is less, density is less. Correct? There is no air over the wings at higher altitudes. Correct? It is very thin air. Understand? You need
Yes,
longer
sir.
runway. Shall I move on?
Yes, sir.
If I am clearing it, it will not come back. Let's assume two places. This is the runway at Hyderabad. This is the runway at Chennai. Same aircraft, both in Hyderabad and Chennai. Today in Hyderabad and Chennai, both temperatures are 30 degrees centigrade and 30 degrees centigrade. Okay. So I'll ask you a different question. Why always only this? Which pilot will bath twice?
Chennai. Due to
Chennai.
humidity, sir.
Yes, sir.
Because of humidity.
Okay. So what is their humidity? See, there is humidity. Explain me why he has to take bath twice. So same temperature, na? See, same temperature, correct? So you said humidity is more in Chennai because it is surrounded by sea, correct?
Yes.
So then what? Then so what? So what? So what? Right.
So
Hmm.
you sweat a lot.
Oh, your body sweats depending on temperature. Hyderabad also 30, Chennai also 30. You said the answer is correct,
Right.
but you don't know the actual
Yes, sir,
why.
Yes.
Sir, I can give a try. Like
Huh?
because I will give a try. I don't know I'm right or wrong. So
Okay.
humidity, the like the what a vapor in of the air is already heavy. Like the air is already having droplets and it's full. So when we sweat, it doesn't go like it doesn't evaporate and it stays on
Very
our
good.
body.
Very good. That is the correct answer. So, so see, your body produces sweat because it needs to cool down. Correct. For example, if you have a cup of water, if this water has to evaporate, what should you do? You should supply some heat to it. The molecules will take up this heat and they evaporate. Yes or no? That means evaporation, the body will produce sweat. The evaporation, while evaporating, it will take a lot of heat from the body and it will, the sweat droplet will become water vapor. Right or not? Correct. And the amount of sweat a human body produces solely depends on the temperature. So if this guy is in Hyderabad or in Chennai, he will produce same amount of sweat. Yes or no? Correct. But what happens in Hyderabad? The air is dry. In the sense, there is not much humidity around me. Correct. So see, there is less water molecules. So it will be easy for the sweat droplets on my body to evaporate and become some water molecules. Correct. But if you take Chennai, there are already a lot of water droplets. Air has a certain capacity to carry water droplets. Okay, water vapor. Beyond that, it cannot carry water vapor at all. Correct. So what happens when this tries to evaporate? It will say no, 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 no. Stay there only. So that guy will be having sweat irritation all day. So this guy in Chennai will take bath 2 times. Understand? It is not because it is hotter. It is because it doesn't evaporate. This sweat doesn't evaporate. Okay, I lived in Trivandrum. Oh, Anil, winter 2 times daily. Now I'm living in Hyderabad. Guess how many times I'm bathing? Okay, don't guess. Now, question. Now an aircraft is taking off from Hyderabad runway and a runway in Chennai. Okay, in which runway, on which runway, it will need more length for takeoff? Is it
Chennai.
Hyderabad, Chennai, Manchi, Chennai. Chennai, who said? Raise your hands. Your voice is low. Harshita.
My answer is also Chennai.
You guys came to Metlas. New students. Hyderabad. Shadab. Zara. Sir, Paiji is sweating a lot in Chennai, na? It is very irritating. So he will not concentrate on the runway. So he will need more length over. Don't give this answer.
No, sir, no idea. I'm not able to like.
Okay.
I don't want to guess.
You don't know, just guess here. Make a mistake here. You will learn it.
Hyderabad.
Hyderabad.
Hyderabad will be having longer runway.
The answer is Chennai. Why? See,
So density is inversely proportional to humidity, right?
correct. Correct. Let me explain here. You have listened it in meteorology and now. That is correct, Manshi. Very good. See, what is the content of atmosphere? Nitrogen, how much? Lower classes? Zara?
78.
Nitrogen is how much?
78.
Oxygen?
20.
21.
So total would be 99%. Correct. So most of the atmosphere is made up of nitrogen and oxygen. Rest all are combined 1%. Carbon dioxide 0.03, etc. Correct. Now, anybody knows the atomic weight of nitrogen molecule, nitrogen atom?
14 gram.
14.
28.
Yeah, I did not ask a molecular weight here. I asked atomic weight. One atom will weight 14 moles. Correct.
14.
So 14 plus 14 will be 28. That is the atomic weight of nitrogen. Oxygen 16 atomic weight. So molecular
16.
weight would be 32.
32.
Yes or no? Correct. So together or average, together how much? No, don't say together. So it is 28 and 32. Correct. So Hyderabad, it is dry. So this is the weight of the air. Correct. Now in Chennai, what happens? See, if this is oxygen, cross marks is oxygen. Okay. So these are oxygen molecules. Correct. So let's say this is nitrogen molecule. I have drawn many. Correct. 78% nitrogen molecules. And there are 21% oxygen molecules. Correct. Oxygen I will drop less. Okay. So these are the oxygen molecules. Correct. Now, see, when there is lot of water vapor, some of the nitrogen molecules are replaced by water vapors. Let's say two of the nitrogen molecules are replaced by water vapor, nitrogen or oxygen, because see, per unit volume, the number of molecules will be same. That means if some new molecules are coming, old molecules should go out. Correct. Now, let's say one nitrogen molecule is replaced by one water vapor molecule and one oxygen molecule is replaced by one water vapor molecule. Okay. So what is the weight of nitrogen? 28. What is the weight of oxygen? 32. Correct. So this is replaced by, what is the molecular weight of water vapor? H2O.
18.
18. That means 28 is replaced by 18, 32 is replaced by 18. Correct. That means if you take 1 liter of air, is the mass increased or decreased? Decreased. Correct.
Decrease.
So what is density? Density is mass per volume. You are taking 1 liter, this is constant. So mass is decreasing of that same volume of air. Correct. So can I say, if there is more humidity in the air, the total weight or density of air will be less. Yes or no?
Yes.
Correct. So write down. More humidity implies density decreases. Correct. Now see, if you take a wing, you know that lift is dependent on the number of air molecules flowing over the wing. Yes or no? Correct. Now, the mass of air molecules flowing over the wing is less when there is more humidity. That means lift generated is less. So when the lift generated is less, you have to move faster for takeoff. Correct. To produce same amount of lift and to be airborne. Correct. So here in Chennai, it will use a lot of runway, while in Hyderabad, it will take a shorter length of runway and take off. Correct. Now, question. If the humidity of air increases, what happens to the performance of the aircraft? Will it increase or decrease?
Decrease.
Decrease. Correct. Here it is performing less. Here it is performing good. Correct. If temperature increases, what happens to the performance of the aircraft? Temperature increase? Decreases. Density decreases. If density of air increases, what happens to the performance of the aircraft?
Increase.
Increases. If altitude decreases, that means altitude means distance from mean sea level. That is the definition of altitude. From mean sea level, if you measure vertical distance, it is called as altitude. If altitude decreases, what happens to the performance?
Increases.
Very good. This is all you need atmosphere regarding atmosphere in this thing. Anshi, did you say something?
So can you repeat the last point? If the altitude increase, the performance will increase or decrease?
The question is, if the altitude decreases, what happens to the performance?
Then increase it.
Okay. Fine. Shall we move on to principle of continuity?
Yes, sir.
Okay. See, what is the difference between a fluid versus liquid? What is the difference between a fluid and a liquid?
So fluid is more thicker than liquid, basic.
They ask liquid versus oil. No. No.
Sir, more tendency to flow.
More tendency to flow. No. Both have more tendency to flow. See, what are the three states of a matter?
Solid, liquid, gas.
Solid, liquid, gas. Correct. So anything which is a liquid is a liquid. Correct. For example, air, you cannot call it as a liquid. It is a gaseous form. Solid, you cannot call it as liquid because it is solid form. Correct. Now you understand what is liquid. Now, what is fluid? See, anything which takes up the shape of a container or flows freely or can be compressed is called fluid. Can I say liquid is a type of fluid?
Yes.
Air is a type of fluid.
Yes, sir.
Correct.
Yes, sir.
So fluid means it can be air, it can be water, it can be liquid. Anything. It can be oil. Anything which flows is a fluid. Flows is a fluid. Correct. So liquid means it is a state. Okay. So liquid is a fluid, but all fluids are not liquids. You understand the difference? Okay. See, when we are talking about principle of continuity, I will talk about fluids. So am I talking about gases only? Am I talking about liquids only? No, I'm talking about both gases and liquids. Okay. Let's say this is a random pipe. Someone who made the pipe did not make it correctly. Okay. Now, let's say this end is A, this end is B. Correct. Let's say you are sending water into this or air into it, whatever. Okay. And the air is getting out at B, or the water is getting out at B. Now tell me, where will the speed of the water will be more? At A or at B? At P. Common sense. Correct. So to explain how the speed of water is more at B, the explanation to this is given in principle of continuity. It simply says here the amount of mass of water flowing through this tube at any point at any cross section is constant per unit time. Yes or no? Correct. Mass flow per unit time is constant. For example, if there is a machine pumping water at, let's say, 200 kgs per minute, this side also 200 kgs per minute should come out, but because the opening is less, they come very fast. Understand? So can I say, according to the definition, mass per time should be constant. This is what I am doing. I am sending certain amount of mass of fluid from one end, and I should get out same amount of mass of fluid at the other end. Now, what are the variables here? First thing, the area of cross section is varying. Correct. At different parts of the pipe, the cross section is different. Correct. So variables. Can someone say what is the second variable?
Speed.
Flow.
Very good.
Speed of the
Speed.
flow.
Here it is slow, here it is fast. Correct. So velocity or speed is a variable. Correct. Can I say sometimes because of high pressure, the molecules can be a bit compressed here
Yes.
at this end. Okay. For example, if this is air, correct? The air can be compressed here. So
Yes.
another variable is density. Area of cross section, velocity, and density. Now, if I multiply area of cross section into velocity of fluid into density of fluid, okay, what will I get? See, what is the units of area?
Meter square.
Meter square. What is the unit of velocity?
Meter per second.
Meter per second. What is the units of density? Density is mass by volume. Correct.
Kg per
Kg per volume is meter cube.
meter cube.
Correct. Now, if I take a look carefully, meter square and meter will cancel with meter cube. Now, what is left? Kg per second or mass per time. Correct. So, can I say this area into area of cross section into velocity of fluid into density is nothing but mass per unit time of the liquid flowing, and this will be constant. Can I say that? Okay. See, if you don't understand this, you will not understand Bernoulli's principle. If you have any question, you ask me. Don't make up questions, sir. Shall I move on?
Sir, sir, can I explain the variables of density? How it will be?
See, I am talking about fluid. Let's assume instead of water, I am sending air. Correct. Here it is very high pressure. Correct, because it is getting constricted. Or see, air density can vary at any point of time. Probably someone has put a fire here and it is heating the air. So density is decreased. There, because density is decreased, it should move more faster. So density is variable. Probably change in temperature across the tube also. So it get compressed also somewhere else. Yes or no? Correct.
Yes, sir.
So density is a variable. Now, how are these three variables related to each other? Is what I thought. Correct. So I just tried multiplying these three. And then I found out, yeah, area into velocity into density will give mass per unit time, which is constant, because I know the amount of matter I'm sending into the tube, this is the same amount of matter I'm receiving at the other end also. Correct. So this is the formula. Area into velocity into density is constant. Clear? How many of you think air is compressible? Can you give an example?
So like car engine, the combustion.
Those are the gas we use in our homes. That's
Very good. Gas we use in our home. So it is a compressed gas. Correct. The air is compressible, but under very high pressure. Have you seen the machines which pump the gas? They push it with a lot of pressure. Okay. Air is compressible, but it is not very easy for air to get compressed. Correct. For example, if this is the wing of the aircraft moving forward like this, okay, the air molecules are hitting this, and morning we have discussed compressibility in the navigation class, adiabatic heating. Correct. That means I said air here will get compressed. Okay, but generally this does not happen at subsonic speeds. Correct. It will happen at a very high speed aircrafts. You understand? So generally air is not compressible below 0.4 Mach. In Mach meter, I'll teach you again in navigation. Correct? So air is incompressible below 0.4 Mach. Correct. Now, in this case, what is constant? Which became constant? Density became constant.
Density.
Correct. Now, from this, can I write, if I am flying an aircraft at subsonic speeds, here area into velocity is constant, because density is also a constant value. Correct. So can I write area is inversely proportional to velocity. That means if the area of cross section halves, velocity will double. If the velocity doubles, that means area of cross section has become half. How many of you understood this?
Got it, sir.
Got it? So this
Yes,
is
sir.
this is the first question I asked here. Because the area is less here, area of cross section is less here, what happens to the speed? You said so speed will increase, but how much? If it halves, the speed will double. As simple as that. Okay, so it is like inversely proportional by a factor 1. Shall I move on? Okay, now based on this, the Bernoulli came out. Now, Bernoulli theorem is defined for ideal fluid. What is an ideal fluid? See, fluid though you know which flows. Correct. What is an ideal fluid? See, ideal fluid is something which cannot be compressed and it will not stick with other air molecule, with other molecules. Correct. So Bernoulli's theorem is defined for ideal fluids. Okay. Now, lot of the aircrafts which fly will fly below 0.4 Mach, your Cessnas. Correct. So initially when aircraft was built, all were subsonic. Correct. So this Bernoulli's theorem was applied for everything. Even for high speed jets, the compressibility is very low for air. Okay, Bernoulli's principle will still apply. Okay, air is close to ideal fluid, but it is not an ideal fluid, but it is close. That's why, because it is not close, that is the reason at higher levels you have something called as shock waves. Correct? MACTEC. We have discussed in MACmeter. Okay, how many of you understood what is ideal? Okay, so it states that, see, Bernoulli's theorem states that pressure plus kinetic energy is constant. See, first, how did I tell that I'll explain Bernoulli's theorem? According to the book. Second, in a very practical sense. Get it? Guys, do you want a break? Do you guys want a break? Let's take 5 minutes break. Let's take 5 minutes break. Okay. I'll see you at 0600 PM.
So can you open that page where you were explaining that density is constant? Thank you.
Okay. I'll see you in 5 minutes. See, Bernoulli's theorem states that if a fluid is in a steady flow, for example, when you turn on a tap in your washroom, correct, the water can come like that. Or if you go to a very good hotel, like 5-star hotels, like the water will come very smoothly out of the tap, correct? And once it falls on the sink, it will not splat, it will spread. So steady flow means the fluid flowing in an orderly fashion, correct? So if, for example, if you take a river, in the river, the flow is turbulent. That means it will go like this, like this, like this, like this. Okay. Or when the water is calm, the water flow will be steady. You know. So steady flow means in an orderly flow. When it is flowing orderly, the molecules will travel in straight lines. They will not cross each other. But when the flow is turbulent, they flow like this. The streamlines cross each other in a turbulent flow. Correct? So the meaning of steady flow is orderly flow. Write down the streamlines do not cross each other in a steady flow. Correct? Now, what is a streamline? If you take a single water droplet or molecule, the path followed by a single water droplet is called a streamline. Correct? The path followed by a single fluid molecule. Correct? So it says here, if the fluid is, first thing, ideal, and if the flow is steady, that means the streamlines are not crossing each other. Then you take at any cross section, here or here or here, A, B or C, correct? At any cross section, the pressure exerted by the fluid, its kinetic energy will be constant. This is what it says. Okay. And there has been an explanation which I believe is stupid explanation, but anyway, it is given in the Oxford, so I'll do it. Okay. And then I will give my own explanation to this Bernoulli's theorem. Okay. Bernoulli 2. Fine. Let's take air is flowing. Air is a fluid. Correct. And air is close to ideal fluid. Correct. Now air is flowing. At this cross section, okay, for this cross section, let's say the area is A. How much? A. The pressure is 1013.25 hectopascals. I'll take normal atmospheric pressure at mean sea level is this pressure, correct? See, 1 hectopascal is equals to 100. See, pressure is force per unit area, Newton per meter square, correct? So this is the true conversion. So can I say here the pressure is 101325 Newton per meter square? Can I say that? So can I say static pressure is this much 101325 Newton per meter square, correct? Let's say here the air is moving at a speed of 100 knots. In meteorology, you would have seen in the jet streams, I would have thought if you convert 1 knot is equal to approximately 0.5 meter per second. If you convert nautical miles per hour to meter per second, it is almost half. So 100 knot will be equal to 52 meters per second. Correct? 52 meters per second. Now, if I calculate dynamic pressure, half into density into V square. This is the dynamic pressure. Correct? So it is half into density of air is how much for this pressure? I say conditions. Where is Manshi here?
1225.
1225
Gram per meter cube.
gram. So I want in kgs. 1.225 gram per meter cube. Correct? Into V square. Speed is 52 meters per second. 52 into 52. If you solve this, you will get 1656 Newton per meter square. How many of you understand? Correct. Now they say dynamic pressure plus static pressure is constant. This will be this. If you add these two values, you will get this value. Am I clear? Now, from the principle of continuity, if the area is A by 2 over here, what is it? A by 2, area of cross section. What will be the speed of the air? Will it double or not? Will it double?
Yes, sir.
Okay. Now let's say 200 knots, 1 knot per meters per second. Correct. Now calculate dynamic pressure. Half into, see, because we took ideal fluid, it is incompressible. 1.225 into 104 into 104. Correct. So if you solve this, you will get 6,624. Now Bernoulli's principle says that dynamic pressure plus static pressure is constant. So the two values should be this. Yes. Now, so because this plus static pressure should be this, you will get static pressure as 96,357. Am I clear on this? Am I clear on this? That means here, if the area of cross section decreases, what happens to the kinetic energy or dynamic pressure? It increases because the air moves faster. Correct. Now, the air exerts pressure on the walls of the tube like this. That is called a static pressure. Correct. So, because the dynamic pressure plus static pressure is constant, the dynamic pressure has increased, the static pressure is decreased. The pressure exerted by the air here is less. Am I clear on this? Now, this is Bernoulli's principle, no doubt. And I will tell my own Bernoulli's principle. It is all given in notes here. I have given you the notes. It is all there. Okay. Next.
So, how did they calculate the static pressure over here?
I assumed it to be atmospheric pressure. I took means I say conditions. 1013.25 hectopascals. If I convert to Newton per meter square, 1 hectopascal is 100 Newton per meter square. It is a fact.
Okay.
Okay. Got it? Okay. Guess what is this? This is an apartment building. Correct? My apartment building. And what is this?
Water tank.
Water tank.
Question. From this water tank, the pipes are coming and giving water on every floor. Now tell me, generally tank is made up of cheap plastic. Cheap plastic? If you make the tank out of cheap plastic, so much pressure,
It will
the
burst.
static pressure will break the tank within few hours. Okay. Generally, it is made up of concrete walls. Have you seen the big apartment tanks? They are not made up of plastic. Probably on a small house, one floor house, you can make a tank out of plastic, but on an apartment building, never plastic tanks are used. It's only
Concrete.
concrete walls. Have you seen anyone over the apartment plastic tanks? Generally not. Okay. They make out of concrete walls. But do you see the pipes are mostly plastic? Cheap quality? Yes or no? Hello? Okay, fine. Okay, is this clear? The pipes are made up of plastic. But give me an explanation. Why is this so? There should be an explanation here. When tank can break, why not pipes can break? Why are pipes made up of plastic? Answer, please.
Because there is continuous flow in the pipe, the water is not.
Okay, so what? So what? See, when the water is sitting in the tank, I have told you, see, the initial water was here at the ground level. Okay, some motor was used to pump the water to the tank. Yes or no? That means the energy from the electrical side is converted to mechanical energy, and that is converted to potential energy, and this potential energy is carried by this water. Okay. Now, this water, when it travels through the pipe, okay. Now, when it is ideal, it is sitting here in the tank, and all the water molecules are randomly moving and hitting the walls of the tank. That's why there is a lot of pressure on the walls of the tank. You understand? So that is potential energy. potential energy is like pressure energy, is similar to pressure. Till here it is clear. Now, when the water starts flowing in the pipes, okay, if I take this as pipe, the potential energy from the tank is converted to kinetic energy. That means water is moving in one direction, correct? Due to that movement, the water has something called as kinetic energy. Can energy be created? Can it be destroyed? No.
No,
Correct.
only transform.
Only transforms. So that means potential energy is converted to kinetic energy. Yes or no? The same energy will come into your tap, correct? Or from your shower, and you will aram say enjoy the kinetic energy to use or clean soap out of your body. Correct? You are using the same potential energy that is converted to kinetic energy on your body. Correct? That means when the water is traveling through these pipes, you see there is kinetic energy. That means here the pressure on the pipes is less. Potential energy or pressure is less. Yes or no? Because the water is flowing. The energy of the water is in the form of a flow towards the bottom. It is not exerting any pressure on the walls of the pipes. That is the reason your tank you should make it of concrete, but pipes you can use cheap plastic. They will not easily break. Till now it is clear. Am I clear on this? Sanisha? Good. Okay. Now, same way, when we relate it to the aircraft, okay. Raghu? Airplane. The do you see this aircraft? Okay. You take this aircraft, you cut the wing like this using a scissor. Correct. If you see the wing like this, after cutting it, okay, this is called the cross section of the wing. Okay. The cross section of the wing is like this. Okay. Now, aircraft is at rest, stationary on the ground. Yes. Now, what happens? The air molecules around the aircraft are in random motion and hitting the body of the aircraft. Correct. So that is called atmospheric pressure felt by the aircraft wing. And how much is that?
1013.
At mean sea level, it is 1013.25 hectopascals, or if we convert, it is around 7 kgs per inch square. That means on 1 inch, let's say inch is this much. Okay. So on 1 inch, 7 of aircraft wing. Okay. On 1 inch of aircraft wing, 7 kgs of pressure is exerted. It is exerted upper also. It is exerted niche also, because air is continuous. Correct. So from all directions of the aircraft, this pressure is exerted. Correct. If it is exerted only on the top, the aircraft wing will break. That is not so. I will get buried into the ground within a second. Correct. But it is not so, because it is exerted from all sides. Till here it is clear. Okay. Now be very careful. Okay. I will mix Bernoulli's theorem here. Now, as the aircraft moves forward, what happens? The air molecules will start sliding over the wing like this in streamlines, because air is incompressible at lower speeds, and also the air is close to a ideal fluid. Correct. So generally the flow will be streamlined. But now if you take the bottom of the wing, the curvature is not so much that it will accelerate. Correct. Do you see where is the curvature more? If this is the center of the leading edge, this is the top of leading edge. Correct. The curvature is more on the top than the bottom. Correct. Now, where will the air accelerate more? Where will it attain more speed? Upper or niche?
On top.
It will attain maximum speed. See, air has to travel this much distance in less time, but air has to travel Below the wing, only small distance, this much. Correct. So air will accelerate more over the wing than under the wing. This is how an aerofoil or any structure which will generate lift is designed. Till here it is clear. Where will the air accelerate more? Above or below?
Above.
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 So air will accelerate more above the wing. Correct? Now, there is something called as boundary layer. What is a boundary layer? See, if an aircraft wing moves forward in air, the air closest to the wing is taken along with the wing. The air in the next layer will be also be taken forward, but a bit less. Correct? Here it will be a bit less disturbed, and at some point, these air molecules will not be disturbed. Correct? So where the air molecules are undisturbed is called as boundary. That means this much amount of thickness of air is being disturbed. You understand? You understand? Now, can I draw a boundary layer like this? I'll draw a neat one. Do you see this? Okay. Now, initially, here the air was normal, it was undisturbed, and it got accelerated. When it was undisturbed, that means the aircraft did not come to this position. Let's say Mike is the undisturbed air point. The aircraft did not come to that position. That means in here, it was exerting in the atmosphere 1013 hectopascals or 7 kg per square inch pressure. But once the aircraft came here, it started accelerating in one direction. Yes or no? Correct. So when it started accelerating in one direction, what energy it gained? It gained kinetic energy. Correct. That means here the ability of this air to exert pressure on the wing, did it decrease or increase?
Pressure should decrease.
Pressure decreases because it gets converted into a directional motion, which is called kinetic energy. Same like the water in the pipe. It is not exerting pressure on the walls. It is giving a kinetic energy so that you can enjoy your shower bath. You understand? Correct. So here on the surface of the wing, it is not 1013. It is far less than 1013. Correct. Now, where is the acceleration more? On the top of the wing or below the wing?
On the top of the
Top.
Top of the wing. So kinetic energy is more above. That means pressure is less
Easy.
above the wing than below the wing. Yes or no? Correct. So here pressure is less when compared to bottom of the wing where pressure is relatively more.
High to low.
Now, so bottom of the wing is more pressure, top of the wing is less pressure. That means a lift is generated in this direction. On every square inch of the wing, lift. So every square inch of the wing, the lift will be generated. You understand? How many of you understand this? Now, let me tell you, how is this related to principle of continuity? How is this related to your Bernoulli theorem? Correct? So now listen carefully. Can I draw here like this? This is the cross section. Okay. Can I draw a cross section like this? So these two cross sections. Correct. So can I draw a cross section like this? 3 cross sections. Correct. So now, if I remove the bottom of the wing, don't imagine the bottom of the wing. If you just imagine this was the initial pipe I made. Correct. Yes or no? Correct. This is one cross section. This is second cross section. Probably it will expand and become third cross section. Correct? So that means Bernoulli's principle tells the same thing. Here, as the air accelerates, its pressure is constant. Sorry, its energy is constant. That means dynamic pressure plus static pressure is constant. Static pressure is nothing but the pressure energy. Dynamic pressure is nothing but the kinetic energy, half into rho into v square. Correct? Correct? So now static pressure is less. That means the actual pressure is less. And that is how lift is generated. How many of you really understand how the lift is being generated? Okay. If you really understand how the lift is being generated, I'll ask you a simple question. How do you drink your Pepsi? How do you drink your Pepsi? Sarisha, you ever been to KFC? Veg or non-veg?
I'm a recent vegetarian. I've like been to both.
Forget it. No more discussions on this. Okay. So now they gave a Coke full of ice cubes. No Pepsi or no Coke in it. Okay. So how did you drink? Sir, I took out the straw. Will you drink like this?
No,
Then
I
how?
drink with a
Then
straw.
how?
With a straw only.
Then how?
Pepsi is there na in the container.
Okay. So show
I'm
me.
drinking with
Show me the container. Show me.
They gave
Ah.
me the mug today.
Okay. No. They gave the straw only. They don't give mugs. Okay. Show me.
Imagine this is straw.
Okay. Okay. Fine. See, for example, this is your Pepsi. Okay. Now there is Pepsi here. There is straw here. Okay. Let's say this is Sanisha. Sanisha, please don't mind. I am a very bad painter. Okay. See, sir, I did not make it wantedly. Okay. It came out like that. Okay. Fine. See, what are you doing when you put this straw in your mouth? What are you doing? You are doing this. That means you are sucking out air. Whatever air is there inside the straw and outside the straw, this was exerting pressure at 7 kgs per square inch. Inside the pipe also there is air that is exerting the pressure at 7 kg per square inch. Yes or no? But what you did, you put your mouth or you put the straw inside the mouth and you took out this air. You created a vacuum. Understood? So when you created a vacuum, here this air is not there inside the straw. The air is not there. It is vacuum. Now the outside air exerted a pressure of 7 kgs per square inch on the Coke. That will push the liquid into your mouth. For example, can you go to a outer space and suck like this? No, because there is no air. You understand? See, same way, here lift is not generated because something is pushing the wing from the downside. Lift is generated because the pressure on the top of the wing is made less when compared to the bottom of the wing. See, you are not sucking the Pepsi inside your mouth. That is what you feel. But actual thing is, you're just removing this force inside the pipe due to air, and the atmosphere is pushing the air or pushing the Coke into your mouth. You understand? Between the real science and the feel what you get. You got it? So in your life, every instructor will tell you that lift is generated from bottom. The wing is being pushed because the air comes and hits here like this. That is complete bullshit. It is because the airflow causes decrease in pressure on the top of the wing. That decreased pressure is less. So that decrease is more when compared to decrease in the bottom of the wing. That will lead to an upward force called lift. The super clear concepts are these. If someone says otherwise around, they are talking nonsense.
So basically, sir, the tendency of the pressure is to move from high to low.
Tendency of the
Pressure. It,
Pressure
matlab, it
or
moves
wind?
from high to low. From high pressure to low pressure, it moves towards low.
Okay, so the wind will move from low pressure to high pressure to low pressure. Yes.
Yes, sir. So we can say that, sir.
Yeah. See, you have created a low pressure area in your mouth,
Yes.
correct?
So high,
And
there's a high
the
pressure.
pressure is high on the surface of the liquid inside the glass.
Right. Right.
That
So
is
it moves.
pushing towards a low pressure.
Yes.
That can be said, but very much error.
Right.
Am I clear on this? How many of you understood, really understood the Bernoulli's principle? Correct. Now you apply this for everywhere. Whenever you see something moving, it has more kinetic energy, less potential energy. Okay. So when you keep things to practical sense, they will really make this thing. Okay. Now tell me, did Wright brothers discover the aircraft first or Bernoulli made the principle first? No. See, the two events were completely different at different point of times. So once the aircraft was getting designed, correct, the Wright brothers correlated these things, correct, and then they said, okay, so Bernoulli's principle explains this, why the lift is being generated. Okay, here whatever Wright brothers have used, the ailerons, rudders, even today in the modern aircraft, we are still using the same technology to fly. So we have not improvised. We have improvised a bit. That's all. Flaps, slats, etc. are there. Air brakes, etc. Correct, spoilers. But most of the flying, 99% of it was discovered by Wright brothers, and we still do fly the same way. No new technology has ever come into place when flying aircrafts. Am I clear on this? Interesting. Class was interesting. Boring.
Yes, sir.
Okay. Now read the theory. Correct. So technical general class will not have much homework except you can do bits from the Oxford. Okay. Here. Next.